Hello, everyone. For today, please get this warm-up from Canvas, print it or download it so that you can work it out and pause the video, then unpause to check the answers, and we'll get started on our class activity after that. All right, so for our warm-up here, we have the solving for the sample size. Remember that there are 3 steps for this. Remember, 1, we divide your margin of error by the z star. And then I'll just put by. Step 2, we square both sides. And then step 3, we divide the numerator by the answer. And then, of course, if necessary, we'll just, no matter what the decimal, round up. Even if it was 0.01, we would round up. This one was a whole number, so we didn't have to worry about it. And then the conservative estimate for p hat is equal to 0.5, remember. That's a 50-50. It gives us the highest possible sample size. And so for number 2, we didn't use 50-50, we used 85-15, 0.85, 0.15. And so I didn't answer that part, but it's almost half the size. So it's a much smaller sample required. That's why we call the other one the conservative, because it gives us the largest possible sample we could need. And then for number 3, I just want to remind you a couple of things. As n goes up, your margin of error goes down. And as your confidence level goes up, your margin of error goes up. And so if we wanted this margin of error to stay the same, then we have to, and we're increasing our confidence, then we have to increase the sample size to counterbalance it. All right, hopefully that made sense to you. And it was just a little review from confidence interval stuff. Hopefully you did well on your quiz yesterday. So moving on to our activity for the day. Is your teacher a good free throw shooter? Well, I think I am. But make sure you get out the activity that says, is your teacher a good free throw shooter? We got a little Steph Curry on there in a basket. And we're going to work through this together. Now, we have done a simulation before about whether or not I'm a good free throw shooter back in probability days. And so we're going to talk about that a little bit still. I still claim I'm 80%, even though some of you might have seen it was different back then. I'm claiming I'm an 80% free throw shooter. That means I make 80% of the free throws I take on average. So in class, if we were in class, I would get a basket. I would get a basketball. We would go to the gym, and I would shoot 50 free throws to show you. But I did this before, and I only made 32 shots. So I want to know, am I exaggerating about my free throw skills, or did I just have a bad day? So take a second to do number 1 and number 2 only, and fill those out. And then pause the video while you do that and unpause when you're ready, and we'll go over some of the answers to that. We'll debrief a little bit before you get too far into the activity. All right, so for the population and parameter sample and statistic, we've done this many times at this point, and we'll continue to do it as we work through this unit. But the population would be all free throws. So remember, if you have trouble with population, you can just start with the sample. I shot 53 free throws, that's the sample. And then just replace the number with the word all, and that is population. Now the parameter is the true proportion of free throws made, which I claim is 0.8. I'm just going to write in red P equals 0.8 because that's my claim. So I'm going to keep that there. And then the statistic is from your sample, 0.64, 32 out of 50. Now there are 2 possible explanations for how I could have only made 32 out of 50 shots. And I prefer the first one, but I could really be an 80% free throw shooter and just had a rough day. I only made 32 shots. This is what we call, basically what we're doing today is a significance test. And so the 2 possible explanations are what we call our hypotheses. So remember, when I write down in red, you write down in red. And so the first one is called the null hypothesis. And the way that we write that, that's kind of like the original claim. I claim, we put a little h with a subscript of 0 for null. And I claim that my true proportion is 80%. So that's the claim I'm making. Now, what I think is true is that, what I don't think is true, I think the null is true here. But it could be true that I am lying and I'm not a 80% free throw shooter. I'm exaggerating. The word lying is a little mean and harsh. So let's just replace it with exaggerating, because we want to be specific about which direction it should be. So our alternative hypothesis is, if the null is not true, then what could be? If I'm not an 80% free throw shooter, then what am I? And so that is your alternative hypothesis. And we have h with a subscript of a. And we use the parameter p. And I don't know what I really am. I just know that if I'm exaggerating, I'm actually less than 0.8. So I'm not going to put 0.64. That was just one time. I'm not saying I'm a 64% shooter. I'm just saying maybe I'm exaggerating and I'm actually less than 80%. So to test the claim, what we need to figure out is, what does an 80% free throw shooter look like? If I'm claiming I'm 80%, we can't take my word for it. We need to see, what would someone who does make 80% of their free throws look like if they were to shoot baskets of 50 free throws over and over and over. So we can't find all the 80% and write all their most recent free throws down. What we're going to do is run a simulation. We've done this before. So you're going to go to nctm.org/adjustable spinner. I'll pull it up on my screen. And what we want to do is use a spinner to simulate 50 free throws shot by an 80% free throw shooter, because not every 80% shooter is going to make 80% every single time. Just because I've shot 64% doesn't necessarily mean I'm exaggerating or lying. I could have just had a bad day, so I want to know, how likely is it that an 80% shooter has that bad of a day? So I'm going to share my screen or pull this over from the nctm.org so you can follow along. We want to model 80%. So this has 6 wedges. I'm going to change it to 5. And then because we are at Ardrey Kell, we'll use purple as our success. So as a failure, as the failure, sorry, Ardrey Kell. And then we'll use the other 4 colors as our success rates. So we'll say 4 of the wedges represent me making the shots, and then the purple one is missing the shots. And then I'm going to cross off all the other stuff. If you just get rid of if you go to the pie chart button, it gets rid of all the extra stuff. And so what I want to do is, I want to spin this 50 times. And I want to simulate 50 free throws. And so I'm going to skip to the end so it does it all. I'm going to hit spin first, sorry, and then skip to the end so we get our 50. You have to hit spin first, apparently. So remember, purple was our fail, miss, and then our blue, yellow, cyan, and red are the makes. So we need to add those up, and we should get 40. And that's 40 for me out of 50. So what I would do on my paper is I would write down my sample proportion of free throws made was 40 out of 50, which is actually exactly 0.8, so that was great. Number 4 says to repeat for another sample of 50 spins. So I'm going to reset, spin. It's going to do it once. It landed on blue, and then I'll skip to the end to get all 50. This time, I only have 6 purples, so 10 plus 10 plus 12 plus 12 is 44. And so I was even better on that one. So 44 out of 50 is 0.88. So each of you are going to do that twice. And if you look here, I've already written down those 2 spins. And so let me move that second one to the second row. P hat. I got 44. 0.88. So then, if we're in class, you can add your sample proportions from the spinning to the dot plot at the board. If you are at home, then you'll use the Stat Collab and you'll just type in your number. Your teacher will create a class code for that. Here's a sample of what the dot plot could look like. So if I had p hat as 0.8, that was one of them right there. And then 0.88 would be another one of my dots. And so those are the two of the dots that I got. And then you guys will each do two of your own. And so that is something that you can create in class, or if you are not in class or it's impossible to create it, then just go ahead and pause this video here and copy this dot plot down. And remember, this is what 80% free throw shooters do. I didn't actually make 88%. That was the spinner that got 88% of our successes. All right, once you have that copied down, go ahead and work through questions 6 through, I think 9. So go ahead and finish the worksheet, and then we will come back together to finish debriefing once you get all that done. Okay, so what does each dot represent? If we look back at that dot plot, we have a proportion of free throws made. And so, you know, one sample here, 92%. P hat equals 92%. That was going to be 46 out of 50. So that would be one sample of 50 free throws with 46 made. And then we have all the rest of the dots too. So that's what I have there. And I'm just going to add for an 80% shooter. Remember, those dots were created from a spinner with 5 wedges, where 4 of the wedges could be making the shots 80% of the time, and 1 wedge was missing it the other 20%. So it modeled an 80% shooter. So when someone says each dot represents the proportion of shots made by your teacher, is this correct? I didn't shoot all those. That wasn't me making baskets 50 times in a row for you guys to copy down my successes. That was a spinner. So no, it was just from the spinners. The actual result that I have was 32 out of 50 that I told you about before. I just claimed I was 80%, and that is what we used with the spinner. So what percent of the dots represent a percentage of 64% or less? We're going to look back at that dot plot to show you that. So we had 61 dots on here, and then this was me, Miss Pendleton's results. And what we want to see is this dot plot shows what 80% free throw shooters are able to do. Now, I had a day where I shot 32 out of 50. Is that likely enough for someone to do just by chance, or how frequently does that happen? And how to do as poorly as I did. So we look at 64% or less, and there's only 1 out of the 61 dots that match that criteria. So that's where that number came from on number 8. And so to interpret it, remember there's a 1.64% chance that I would make 32 out of 50 or less free throws if I am really I need to add that at the beginning, because that 1.64% was based on an 80% free throw shooter. Now, some people like to look at this dot plot and they'll say, oh yeah, look, Miss Pendleton is an 80% free throw shooter. Look at all those 80%. She had so many 80%. Remember, this was not me. This was a spinner. This is what an 80% free throw shooter should look like if they're telling the truth. We do expect some variability. We expect them to make less than 80 sometimes, more than 80% sometimes, exactly 80% sometimes. But the question we're asking now is, how likely is it for someone to do that poorly just by chance, just by variability? Is that variability something we'd expect, or is it really so unlikely that we are suspicious now? And so what this is called is, both of these are really important. They're called a p-value. It's the probability of getting results just by chance alone, if that null hypothesis was true. Remember, 80% was the null hypothesis we wrote about on the last page. And so that's the p-value. The p-value itself is in number 8, and the interpretation is the next section of number 8. And so what do we do with this p-value? So like we said, it's very unlikely that I would be that unlucky if I really am an 80% shooter. So do we have convincing evidence? We've talked about this so much from our previous units, and we do actually have convincing evidence here, because it's very unlikely that an 80% shooter would do that poorly, and I'm going to add purely by chance. And so because it's so unlikely for that to be a chance occurrence, then we think, okay, well, it must not have happened by chance. She must really be exaggerating and be a less than 80% shooter. One thing we can also do is compare that p-value to that percent we've been using, 5%, which we call the significance level. And so we've used that 5% before. It has a special name to tell us if data is statistically significant or not, and we'll talk about it in our notes section. But that 5% is kind of like our cutoff point for what we consider to be anything less than 5% we consider to be too unlikely to have occurred by chance alone, and anything higher than 5% we consider to be not that suspicious, and we will not have convincing evidence. So this is called our conclusion. And what we basically did here was we did a significance test to see if we have statistically significant evidence against me for my claim about being 80%. And it started with a null and alternative hypothesis. And then we did a simulation to see how likely is it that I would be that unlucky just by chance. We then got a p-value to make that calculation and concluded at the end. And so we'll have a 4-step process to follow for this as well. There will be conditions. We'll do more of that next class. But in the meantime, you can go ahead and copy down these 3 important ideas for the basics of a significance test. And I want to add one thing to this, so don't pause me just yet. The null hypothesis was the original claim, so I'm an 80% shooter. Alternative is whatever the alternative option was that I was actually exaggerating in this case. So it could be a less than sign. I could be talking about being better than I actually am. And then I meant to put this on there, this not equal to sign, not an equal. We already have the equal in the null. And then really, it could be P or mu. And so it just has to be a parameter. So I'm just going to add that note. So for us, that's going to be mu or P. Then we have the definition of p-value, the significance level definition, and then how we make a conclusion. So we either can reject the null hypothesis and say the alternative was true, or we can fail to reject the null, and then there's not enough evidence to conclude our alternative. So give this a pause, write it all down, and then try to check your understanding and come back for some additional notes on that. All right, so this is why I had to add that note about the mu. The null could be about a mean. So when it says on average, then our parameter is a mu, not as p, mu for mean. We always have an equal sign here. And then for this sign, we got it from, I'll do a quick highlight, our not getting enough calcium. And so that's where we got the less than for the HA. So that's your clue for what sign to use there. A couple other notes. These are always the same number. I'm going to highlight these. They should be the same number. And then you have to define your parameter. So let me highlight that too. Be sure to define the parameter. So here I'm defining the parameter. Have to do that. Oops. All right, next thing, the null to be true. That's pretty straightforward. Just what does mu equals 1300 actually mean? Helps with defining the parameter. And to interpret the p-value, a couple of things. So this first part, we have basically what we want to have is if the true mean calcium intake for teens is 1300, that's really just saying if the null is true, then the probability of obtaining a sample mean intake of 1198 milligrams or less purely by chance is. So that part of obtaining a sample mean intake 1198 or less is the part where we had at least as extreme as the sample. So I'm just going to add that little note off to the side. And then for our conclusion, we have anytime, remember in the notes, we have p-value greater than alpha, then we fail to reject HO, not enough evidence to conclude HA. So we have to do those three things pretty much: compare, fail, or reject, and then there is or is not enough evidence. And we'll work on that a lot more next class. It's really important that we say fail to reject and not accept, because I don't have evidence that the null is true. Our sample mean was 1198. That is less than 1300. I don't have evidence that the null is true. I just don't have enough evidence that the alternative is true. So hopefully that makes sense. You can try out some problems in your homework and email if you have any questions. Thank you so much. Have a great day.